Hello.
Hello, this is SK Hynix America.
Hi, it's Judika from Synopsys.
Hi.
No.
Good afternoon. I apologize for being a little slow. We just got out of the GPU meeting. The good news is we're having this discussion on GPUs where we're aligning the GPU work stream with what we're doing better. So there's some progress there. Uh, anyway, and it looks like you're stuck with me today. Yogesh is out. So I do have a few topics I want to bring up. But while we're collecting topics, does anyone else have something they want to, like let's collect our agenda today. I'm grabbing a pen to take some notes on it. So what are our agenda topics today?
I have a site open, I would say, not an agenda topic, but did we get the photos from the Global Summit somewhere where we can share them?
Oh, I'm sorry. If no one else has done it, I can make a Google Photos share if y'all want. And then just share it. Okay.
So we can share all the photos we had, right?
Yeah, I would love to get pictures. Some pictures. There's some great discussions, and it was a lot of fun.
That would be great. And also, I don't know if we can get a pass down for those of us that unfortunately missed the summit.
Yeah, absolutely.
Yeah.
Let's put.
Thank you.
Yeah, let's have a. Well, I think what we should do is circle around and just give have people talk about what happened and give some feedback. So, absolutely, I'll put that on the agenda.
Appreciate it.
So summit follow up. Um, okay. I think is Anil here today?
I don't see him yet.
Huh. Okay, because I wanted to talk about what's next, and I think we'd like to get the in-band work moving. Um, I don't understand the problems that Anil has brought up. So what I would like to do is work with Anil to, say, hey, what's your plan, and kind of figure out the in-band pain points and get Anil to do something, to start something to address them. Go ahead, Rama.
Yeah. I think like we talked about PCIe in band, and I think we also discussed a little bit. Can we prioritize the PCIe? I thought like many people interested in PCIe. Okay.
Absolutely, yeah, and I think that's also a thing we need to work on. That and air injection, right, are the two big topics I think we have.
Yeah. Like I think I think we can list the next few things and maybe prioritize based on what are the pain points. Then maybe like go with the flow. Maybe like PCIe, like in band, whatever the flow we decide as a team. But I would
Okay.
like to watch for the previous discussion on the PCIe. Everybody agreed. Hey, let's work on the PCIe also. Yeah.
Yeah, and I've been working on some of the PCIe stuff, and I'm working with one of the CP vendors, and I need to get them to give me permission. But the stuff I'm talking about with them is just like AER settings. It's not particularly proprietary. So what I'm hoping to do is kind of bring back some thoughts on like like a sheet we could fill out that would say, here's what we want to do for each kind of error. And then the other thing that we're thinking at Google is that the AER stuff in the kernel, like in the Linux kernel, doesn't seem like it's under a whole lot of active development. And we were thinking maybe we could add some code to enable the AER stuff in the kernel to log in a more structured way, so we could pick those logs up and associate them with other logs we collect. And of course, we'd like to collect it out of band as well. But
Yeah.
that may play into like Anil's desire to improve in-band logging. I don't.
Sorry. Yeah. Less small thing. Like I had to drop. Sorry. Like there is some urgent call they're pulling me in. I'll rejoin back after 15 minutes.
Okay.
Sorry. Yeah.
Okay. So I think that we have some topics. Does anyone have Anil's like phone number, or can ping him? I might be able to. I'll see. While we're talking. So I'll ping Anil, and then I think, why don't we do a roundtable on the summit, and just like talk a little bit about how things are going. So does someone want to start? And I've got notes, so I can do mine, but I'm going to ping Anil while someone else talks.
And Drew, you're looking for general comments of what we saw in the summit, or?
Yeah, well, I think we just a roundtable on how things went. I think is it Jyotika? Am I saying your name right?
Yes, correct. Thanks.
Okay, I try. Please bear with me. And I'm sorry. right before we do that, Jyotika, I want to mention someone. Because I was looking up there and I saw Mita's picture. So I met Mita at the OCP Global Summit, and some of my colleagues had met her at the Grace Hopper. I guess you call it. What do you call it? A Grace Hopper Summit or something?
The
Uh,
conference,
yeah,
yeah.
conference. And she talked about memory errors, and so they pointed her my way, and we actually met at Global Summit, and so we strongly encouraged her to come. And so Mita, I'm super excited that you're here. Mita's looking at all sorts of error things, and we're just really glad to have you. And so, Mita, would you mind introducing yourself a little bit more?
Yeah, thanks, Drew. So yeah, I'm Meeta. I'm from Pure Storage and super interested in the work being done here and stuff that you guys are discussing. I don't know if there's like a running document or something that I can use to catch myself up, or I'll just like do it as I listen over the next few weeks. But thanks, Drew. That
Yeah.
was really
Our minutes are usually the videos. They get linked on the website, but the other thing that we can do is, have you seen our fault management requirements submission?
where would I see that? Like where would that be from?
You can go to the overall submissions, but I'll just paste a shortcut to the doc. So a lot of what we've been talking about is here. Also, if you look at we have a wiki, and the wiki has a bunch of other documents. Like I think Mark, did one on CPR, and we've had huge adoption of CPR since. But and I think Anil's got a few documents up there. So this is what we've been working on recently, the document I just pasted.
Gotcha.
And then our wiki has more, and I'll find the wiki.
Okay, great. Thanks.
Yeah, and it was awesome to meet you. With that, can the folks want to jump in? Like, you want to talk about what happened at OCP, and I just give people like Jyotika a feedback on how things went.
I missed the conference, so I wasn't
Yeah.
there. But
Well, I know. I mean, I meant to give you an update, not to make
yeah.
you.
Sorry. Yeah, I was traveling that week. Unfortunately, it collided with the same week. So apologize. I couldn't make it.
So anyone?
So this is John. So I'm the steering committee rep to the hardware management project. Spent most of Wednesday at the hardware management track. I think it went very well. We were pretty well attended. I went around to some of the other meeting rooms, and they were not as well attended. And so I think the download was that it was record attendance. It was 4,400 people. And so I believe Kate had sent out a last look of the conference, how many companies were there, sponsorships were all filled out, and who were the analysts that were actually at the show. So the foundation was very happy with the show.
Oh, that's awesome.
I think as a community, the other place where we had relevance was in the CSM, right? Where there were some forums, some panels, and we had discussions about in-band versus out-of-band. So that also was fun.
Yeah. And I think, what I would say is I felt like last year we were all trying to figure out who did what and who was working on what. And this year, I felt like when I went to other talks that weren't in our area, they would mention, oh yeah, and we're tying in the hardware fault management. So I feel like we as a group have gained the visibility and traction across other teams that they know to come work with us on things. And one thing that was one of my favorite moments was when I was talking to Samir from ARM, because we're inviting them to work with us on things like the RAS API and a few other topics. And so he stopped by to see us while we're gathering for drinks one night, and And they kind of like, oh wow, he saw this and said, oh wow, you all have critical mass. You know, this is quite a collection of people working together, and you know, he understood immediately the value that this group could bring to the things that they need to do with RAS. So I felt really good, you know, from my talks with him, and also just being able to say, look at this awesome group, you know, and the breadth that we've got. So there are a few other things that came up. One is that, like at Google, we're trying to improve air injection, and we've been trying to, for instance, improve air injection for memory to the point where we can inject errors in a way that stresses the processor's ECC. So we're not just uh, you know, checking error logging systems, but we are actually, we've done some investigations where we have done work to say, you know, does the ECC detect things that we expect to detect? Does it correct the patterns we expect it to correct? Do we get the rate of SDC from memory that we expect, which thankfully has been the case thus far and is thankfully vanishingly small. But so as in part of doing that, we've been trying to clean up some of the EI and J air injection things. And I just want to call out Leo Duran from AMD, because we have some things in the latest ACPI spec, but Leo caught some of the problems and is in the process of helping us fix them. And so we'll probably be bringing additional air injection things out. And, you know, Leo so far has been willing to help. But, you know, of course, we want help from Intel too, and other vendors. But, you know, I think as we do the air injection work here, we're starting to get the right contacts. Leo worked with a guy named Harb at Ampere to align on the air injection because Harb had written the previous ACPI version. So anyway, I think there's some traction there. And I think that if we do air injection stuff, we are set up in a good place that key people working in ACPI know what we're doing and want to help. I also spent some time talking to Jim Bodner and Lydia Warrens from NVIDIA. And they are both aware of our desire to see CPR error logs from hardware. And they're also interested in, you know, talking about things like, you know, PCIe error handling. And, you know, I think one of the things we're going to need to work through is how we handle poison TLPs. And so, yeah, I think we've got some interest there. So if we work on PCIe, I'm hoping that we can, you know, connect with people like NVIDIA that make key PCI devices. We also had some good talks with Jeff Otter and Jeff and John. Because, like for instance, with the RAS API, there's a desire to steer that towards DMTF from the ARM side of things. And so, you know, we need to go take that back to the RAS API group. But, you know, from our early talks with Jeff, and John, that seems doable. And so, you know, we just need to figure that out. I also spent some time with Dong Wei, who is the kind of the ARM specification lead, I think. I mean, he's a fellow there, and you know, they you know, they're getting more comfortable with the RAS API, and we're trying to get lined up with them and what we can and cannot do in the ARM ecosystem, and they are going to, they're supportive of NVIDIA and Vikram helping us with the RAS API and showing us kind of the more PLDM ARM approach. I spoke with, thanks to Yogesh's help, I had a few minutes to chat with Zane Ball and explain the value of what we're doing. And, you know, Zane seemed to pretty happy about it and pretty interested. And Antonio, you'll be glad I talked up the RAS API work and just the overall desire to standardize the plumbing for error handling so that silicon vendors didn't get pulled a whole bunch of different directions. We standardize the non-secret sauce, we make it easy to use, and then we free the silicon vendors up to go off and innovate because they're not trying to meet a whole bunch of disparate needs that pull them in opposite directions. And I think Zane, intuitively understood that as I was explaining that to him. I talked to Henya Hua, I think is how you say her name. She's a vice president at Lenovo. And Lenovo is not here. And so I am concerned that they are missing out. And so applying a little bit of pressure to get them plugged in so that they keep up. I had good talks with Vilas. It was great to see him. I spent some time talking to Steve Lyle at HPE about Superdome RAS and some of the things they're working on. And I think that, even the things we're doing here may play into things that help them. And then, of course, spent a ton of time with Anil. And, they're aligned with CPER. Neil gave I think Anil's presentation was very good. His PCIe air handling presentation that he reviewed with us here, I think it was well received, and it kind of highlights some of the PCIe errors we have and need to work on. And I'm sorry, I took notes. I'm reading from my notes. That's why I'm so long-winded. And I think it was great to see the memory vendors and chat about how we're going to build these analyzers. And I think Google, we're ready to start kicking the tires on a few of them as soon as they're ready. So we would we want to see some analyzers so we can get them in our hands and start giving feedback. And so one thing we may want to do here is another future topic is talk about analyzer interfaces. Because we've talked about the vendors collect the data, and we've talked about the vendors analyze the data, but we probably need to work on the interface to the analyzer a little bit. And I think that's it. Does anyone else have anything?
I would very much like to see the analyzer interface standardized.
Awesome. Well, Hank, I've got a document I'm working on inside Google that says how we want to do it, and our intent is to share it with silicon vendors. So I'm going to try to get permission just to drop it here as a proposal for people to shoot at. So in other words, I'm not trying to step on anyone's toes, but I'd like to just make a proposal, and we can take shots at it and fix it till we get it right.
Do you think that's going to be in a JSON format or XML, or how does that?
Well, yeah, I mean, I think CPER in, JSON out was my thought. And just JSON because everyone can use JSON, right? And the thing that I think is key for the analyzer output is that we really, 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 really don't want to use regular expression parsing to make sense of what the analyzer is telling us. So what we need to do is make sure that we have the appropriate JSON fields such that we have kind of one thought in each field. In other words, I don't want a field that says CPU dim uncorrected or CPU, sorry, not CPU, dim 3 uncorrected error. That would be a terrible name for an error because it has the dim number in it. That what I would like is, memory uncorrected error, and then another field that says dim 3. So, if we structure the JSON fields right, we can avoid regular expression parsing and make it really easy to use. So anyway, those are my thoughts, and I think we want the analysis output to include kind of the name of the error or some sort of identifier, so that if I go to a vendor and I say I have error XYZ, it is a specific name enough that the vendor knows exactly what their analyzer told us. We'd also like it to call out the chipset notions of location. and if possible, the silkscreen, name of the location. But that seems unlikely. We'd like it to give us some some actions we could take. So kind of tell us the cause, and is there a RAS action that we could use to improve the reliability of the machine, or do we need to dance a part or replace a part? So those are the kinds of things that I'm putting in the spec, and I would like to see in JSON. But I mean, hopefully that's just
as a manufacturer, we would also like to see the silk screen.
Yeah. The problem is that like let's say that I give Intel an Intel error log. Intel logs things internally based on its chipset's notion of the numbering. That numbering doesn't typically reflect how the system is silkscreened. Inside HP, when we merged with Compaq, we had one group that liked to number things starting with 0. We had another group that liked to number things with 1. And I'm sure that that is not an unusual problem in the industry. So, someone might have CPU sockets 1 and 2. Someone might have CPU sockets 0 and 1. The chipset typically numbers starting with 0. So we have to basically have some way for the CSP to take the chipset number and translate it to the labeling that's on the machine. And that is a general problem. If there's a general solution, it'd be awesome. But at the moment, I was just expecting that was the CSP's problem, that they just need to know, how the chipset numbers line up to the numbers that are silk screened on the enclosure. But if you all have ideas, I'm open to it.
The number 0 versus number 1 is common across the industry.
Oh yeah, and I've even seen it in cache numbering. We have mid-level and last level cache. So I got rid of the confusion. So absolutely. So that's why I don't think it's that realistic to have the CSP's notion of what something is in the error log. But maybe the CSP could tell the chipset, but I don't know. But anyway, I'm working on that. I think I've got the coders in my organization to line up on what we want, and so I'll try to share that as soon as I can, as soon as they let me. Okay, so is there any other summit follow-up that we want to talk about? Okay, well with that, so we, I guess, let's see if I heard back from it. Neil didn't respond. So yeah, I want to go on the record. We really need to work on in-band. And so what I would like to propose is, and I can help Anil with this, but that we collect the in-band logging pain points and then, empower Anil and other folks that are interested in doing the in-band logging to work on that and then bring some of the work that they do into this meeting and into our discussions here. At the moment, it's not the burning priority for me and for the work I'm doing at Google, but I acknowledge the value of it and want to support Anil and make sure that that we give him an avenue to address some of his needs, because he's graciously let me address some of my needs. So with that, I think we have PCIe pain points and air injection to discuss. What do we want to look at the PCIe pain points next? Is that what I'm hearing? Or does anyone have an opinion?
Where do we have is that two different lists, or that is one list that we have somewhere?
We have two things. We have a I'll put I'll put the documents. I'm pulling them up. So first I'm going to paste the pain points document for PCIe. And we've encouraged people to put some things there. I've actually but only Anil and I have done it so far. So maybe what we do is we get people to spell out their pain points here, and we start filling the document out. And then there's an error injection doc as well, and I'll send that out. Okay. And the error injection stuff is right here. So I'm you know I'm desperate to solve problems with both of them. So take your pick. You know, what do you want to work on? Should we maybe talk about pain points in PCIe and document some more?
The only document I can access is the error injection one, so my vote would be there.
Oh yeah. Let me. It says anyone with the link. Oh, but it's a Google internal doc, and it's preventing sharing with anyone. I don't know. I'm reviewing the requests for access and are sharing them as we speak. So I'll try to. So if you hit refresh, Amita, you should be able to get into the PCIe doc.
Okay. Yep, I'm in. Thanks.
And Antonio, I added you as well. Okay.
Thanks.
Oh, I'm so sorry. I don't know why that document is so restrictive. So I'll try to figure it out. I think it's because it's a doc I started from my Google account in a Google share here. I just started it really quickly in a meeting, and we have all these settings that control what we can share. So I'll sort that out. Okay. So you know, what do we want to talk about? Air injection or PCIe pain points?
Let's do the injection first.
I'm sorry?
I think the error injection has a lot more, so let's start with that one.
Okay. Well, and I think, okay, I'll share that doc. Let's see. So one of the discussions we had, you know, talking to across companies is how to enable air injection. And I think I'm just looking through the doc. I don't see. I think that we need a section on enabling it. So okay. So I'll work on that. And can you see? Am I sharing successfully?
Yep.
Okay. So I'm going to just go through the doc briefly and remind people. So I have a problem statement that just says, "Hey, air injection is super important for testing." You know, and we need to be able to do it at scale. And the problem that like we have at Google is we have a regression fleet that we use for testing all kinds of things. You know, we grab a few machines and we do some testing, and then we let them go, and someone else can grab them. And that's really what we have to test with. So we can do some lab work with early machines with special hardware. That is fine, like for very early prototype testing. But when we start rolling out firmware and software for our fleet, we need to be able to do testing at scale and with a high degree of automation. And so that's really the crux of the problem for me, is that, you know, we need these software driven air injection capabilities that allow us to test our solution. And so, you know, the what severity do we want to inject? I mean, the simple answer is all of them. What blocks do we want to inject? Well, all of them, but we probably ought to prioritize them because we don't want to bite off doing it all and then failing. I think if we can pick a few key areas where we want to invest, that'll probably be more successful. Do we prefer in-band, out-of-band? Neil is saying both, and I kind of agree with him. Both have value. The other thing I've seen some air injection capabilities where you need to like rebuild firmware and you need to change all these settings, and what you end up with is this highly tuned system configuration for injecting an air, and that is the opposite of what we want. Really, what we want to do is flip some appropriately secured setting that enables air injection, and then we can inject any air that we want. And so that'll be something that, and I think we'd like to have a 0.9 or 1.0 spec by Global Summit next year. I think we slipped. And so I tried to define terms, and we've reviewed these before. Spoofing is loading error log values into the registers. And it might cause some side effects, but it doesn't really simulate all the hardware side effects of a real error. And it's useful for testing our framework. It's useful for gathering data, and we can spoof at a much higher rate than we can inject because you don't crash the machine as much. We can just inject the error logs and make sure our logging infrastructure gathers them. So spoofing is useful, but at some point we need air injection, and that causes hardware.
So throw just
Go
to
ahead.
stop you there. In the
No,
spoofing,
please
Yeah,
jump in. Thank you. So go ahead.
Can we add, like, when is it better spoofing than error injection, or what is the value? Yes, it has some usefulness, but why do you need anything else, or where is that limit of where does this runs out of gas, the spoofing, so we can start delineating those fuzzy limits, like where is better to have an error injection than a spoofing, or what should the question be, or what should we be answering?
Yeah, I think we have that here, but we can put this in a table to make it clear. It's really like spoofing is great for error analysis tools. I can shove a bunch of errors into the framework, make sure the error analyzer gets them and says the right thing. And it's fine for error logging frameworks that are just like reading a bunch of registers and making sure they read them correctly. But the problem is it's missing some of the side effects. And so like if I inject a viral error on an Intel machine or a sync flood on an AMD, we're going to stop running code. And so if I spoof that error, I might log a viral or sync flood error and say, hey, I logged successfully. And then I do it on the real hardware, and the real hardware just freezes in band. And all of a sudden my error logging doesn't work. So when you're talking about the software firmware handling the side effects, that's the key.
But then, is there a counterpart there about how accurate is? If, for example, if I have to put a different firmware, then the same side effect failure could be there, right? If for error injection, for example, I give you a different firmware, right? What makes you think you're going to see the same error signature at all, right? If I give you a new firmware for this one.
Well, usually it's the firmware just flips a bit somewhere in the hardware. It says unlock error injection. And if that's the only difference in the firmware, we don't love it, but at least we're confident that we didn't change other stuff. We can look at the firmware image and go, what changed? If it's just a setting in a register that enables air injection, that's less concerning.
Yeah, I mean, I think I would state it a little differently in that I think there's a hard requirement that your air injection capability has to be present in a production ROM. So it is the production ROM that you use. And you know, the injection needs to be against that, not a debug ROM, but you know, actual production.
Today, we can't sign a ROM that has air injection because of denial of service attacks. So we may need to investigate some way to enable it so that we can use a production ROM. Because I agree with your sentiment, Mark. I just don't know how to do it today.
Yeah, the problem is if you're not testing against a production ROM, then you know you're not testing what's actually going to be running in production, and that's the
Right.
problem, right? Now, I would agree it's, you know, it's difficult, and but that's why you put the, you know, the point in, you know, how do you enable it? Because ultimately that's the key, right? You do have to have it protected, and there has to be, you know, mechanisms in place to make sure that you know, those capabilities aren't, you know, actually put necessarily into production, right? But the idea is that I think you still have to make sure you test against what you're actually running in production. If you're doing anything less than that, you're not, you know, you're not doing what you need to do.
Yeah, I think you're right, Mark. And I mean, what we do today is we just say, well, we have an air injection ROM, and we validate that the only change was that, you know, we enabled air injection. It's not great though. I mean, there's a difference.
Yeah, we have a production ROM that has an option to enable air injection.
Okay, and yeah, we're not allowed to sign that. Yeah, we have to sign the ROM, and there's like a chain of there's some security stuff that prevents us from doing that. So we've kind of got a problem there, and it's not ideal. We just live with it. But Mark, so Mark, I I agree with what you're saying. There's a security problem we haven't quite solved yet. So maybe that can be part of what we work on here is try to figure out how to solve some of these enablement problems.
Yeah, agreed. The idea is, but you know, I mean, we do what we do because customers demand it, right? They're
Right.
demanding the ability to do air injection, and you know, I can't ask the customer to do that in a ROM they're not going to be running in production, right? So you know, the idea is it has to essentially be one and the same in order for it to be valid. But I won't argue the point you're making about security and how bad it is right now. There's, as far as I know, there's no good answers here, right?
Yeah. So server, vendor, customers insist on. Yeah, I think there's a disconnect here. Yeah, and we need to work on it. Everything you're saying resonates with me, Mark. I completely agree with you. It's just I don't know how to do it. So, like that would be awesome if we can come up with some better ways to enable air injection here, where we can convince our security teams that we're not setting a denial of service situation up. That would be amazing.
Yeah. Now, one other comment I would make is I think the expectation is that you're not required to do your injections in the production environment. In other words, if I have air injection enabled on a server to be able to test it, I am typically not in my production environment. I'm in a test bed outside of the production environment. And that part is acceptable. But
I think that's where we're a little different, Mark. Our lab machines kind of go away, and we do everything that we can in production. Just because if we test in production, then it works in production. So
yeah,
it's a little different here.
yeah, and see, that's where I would be very cautious because as you say, you're going to expose things if you turn on air injection. And my thing is, I would prefer to do that outside of production, right? Some in a let's say a production-like environment where I can do things like turn on air injection without risking the rest of my production environment.
Right. We can isolate that, but I think that's kind of like a CSP's problem. But like we do things at a scale where it would be hard to have a dedicated lab, but we can go grab a section of our fleet, wall it off, and then do some testing. So that's just a
So,
CSP problem, I think.
so I think that it'll be good here to have like use cases, like validation use cases for error injection, because it seems we have several very different, and it will be good like having it them outlined at the beginning of this white paper, I guess, that we're doing for requirements. Like this is the 2 ways or 3 ways in which we use error injection, and every fleet is their own, but this is the generic 2-3 use cases. Same with security, right? This is the 2 or 3 ways we know how to enable security here, right? Because I think they're pretty common in the industry. There's like 2 or 3 ways we do this. I don't know. Maybe there's one for everyone, but
I'm all for it. I mean, and we kind of did that. One of the things that was really helpful that we did on the requirements document before is we said, hey, there are application providers, there's bare metal providers, and we came up with these use cases, and that enabled us to make progress. So I like what you're saying, Antonio, and I think Mark, like Mark is right on, right? That they have a certain set of use cases as a server vendor that they want to test. And since we own Google, we own like the whole stack, and we have, it's our employees fixing our own machines. We have a little bit more of the stack that we want to test with air injection, and so our use case is a little different. I think if we can highlight those different use cases, then we can make sure that the injection capabilities meet them all. But Mark, I just wanted you to hear. What you're saying resonates with me. I'm tracking with you. So like maybe what we can do is get your use cases and the kind of the CSP use cases in the doc, and then what we can do is boil them down to the minimum set of use cases that span everyone, and then we work on those. Is that okay with you?
Yeah, that's fine. Yeah, the problem is, I think here, much like the management solution, there's likely to be a range of answers, right? Or a range of things people would want to do. It's not just going to be, BMC centric. There's going to be, some, OS integrated, some platform integrated, and some BMC integrated, and a
Yeah,
mix of all.
I think you're right, actually. OS, or I'm going to say OS driven tests, and then BMC driven tests, and if that's okay, but I think I'm tracking with what you're saying. Like if we're testing OS poison consumption, that may be like driven by the OS because the OS is trying to set up a particular test. But if I'm trying to just make sure the machine is generally resilient to something, I may beat on it from the BMC because I get a little bit more variety as to what the OS is doing that way. So
Yeah,
I think
there's certain things the BMC would definitely be much better at, but the example you gave, I think, is perfect, right? If you're doing, SRAR, you're likely to have a victim app, right? It's
yeah,
all going to be OS.
yeah, and I'll just put that as an example. Yeah, I think we're. Yeah. Okay, So why don't we? I can work on that some between now and then. For the use cases I know about. What I'll do, maybe what we do is we put the use cases above the terms because they're really the guiding thing that we're all going to try to, we're going to try to address use cases. So what I'll do is make a use cases section. Okay. And then I guess can folks, what do we want to put in a use case? So we want a name. We want a description. And we want information about a software environment. The key thing we are testing, probably interesting, and in band versus out of band.
Security measures. Security measures.
Or how about security? Yes. Or how about security requirements? For that use case.
Perfect.
Yeah. Good. That's good. And Mark, I was just trying to synthesize some of the things that you had mentioned, but please speak up. I mean, if anyone has things we should put in the use case, that would be useful now.
Drew, just a question.
Sure.
Would you like to add DDR or memory versus PCIe?
Oh yeah. I think if you look down below, we've got like a gigantic
Yep.
a gigantic list. So I'm assuming the use cases are more about like situations where we want to do testing, and then in if let's say that I'm in the lab, testing the machine's behavior. I would inject a whole bunch of different errors, right? We're gonna do memory tests, I/O tests, CPU tests. Good, that was a good point there.
Is there any interest in doing manufacturing tests?
Why don't we do this? We'll say lab production manufacturing. Yeah, good. That's good. Thanks, Hank.
I think that covers my other comment that I was going to say about scale. So include in the description the scaling of this use case. But I think this one covers it.
Yeah, I mean, like I consider the work we do in the lab like really small scale, and then when we do production level air injection, it gets a lot bigger. And then manufacturing's kind of big because, well, it depends. You don't necessarily inject in the course of building every machine, but maybe we would in certain circumstances. When you think about that,
it would help. It would help in the discussion or the diagnosis of the connectors between the boards.
Oh, interesting. Okay. So Hank, what we'll do is we'll fill out these use cases, and we may need you to help us there. So I got reorged into recently into a team that is closer to factory diagnostics. I mean, we still cover R&D, we still cover the development of Google's hardware, but we also support a broader range of things in the team I'm in now. And so I probably ought to be thinking more about manufacturing than I do. So that's a really good topic. I'd love to get your insights on it.
Drew, what are the use cases of error injection in production?
So we do it. We have production machines that are regression fleet, and we might be testing, like a daemon that's monitoring disk space. or we might be testing a new firmware release, or we might be testing that our fault management solution still logs errors correctly. And we use this regression fleet for a wide range of tests, but the key is that it is in a production environment, so we're testing all of our features in the environment that they're going in, so that we know that it works in that environment. Because at the end of the day, for us, we're not like HP has to make sure sorry, Mark, has to make sure their servers work all kinds of places. We don't. We need to make them work in our data center, so we test just in our data center.
So it's a flavor of, it's a production data center, but it's not like a production application is running on it when you're doing this. So it's a regression.
We may need to clarify that, but yeah, what we mean by production. So I'll work on clarifying that. I call it a production environment, not in, it's not literally running a customer workload.
Right. So, okay. So it's an at-scale environment, but more for regression. Yeah.
Yeah, I'll try to figure out a way to, we just call that environment prod for production, but it just means in the data center with all our data center automation in place. And that doesn't necessarily imply who's using it or how it's secured. We can wall off that work, but it's running, under all of the workload coordination stuff and the software that controls the firmware and OS versions, and it also has the data center monitoring solutions connected to it. So that's the important thing, is that all the framework is there, and we're testing in that framework, and it works correctly when we inject an error, and the error bubbles up to something that's monitoring that machine and diagnoses it. But we do not mean customer workflow. Oh, sorry, go ahead.
Hey, Drew, would you like to add anything in there about JTAG? Just a question.
I guess we could say, I'm going to say injected via, like the software, JTAG, special hardware, and I think we have some of those cases listed below. Yeah, so like here are the things that I identified when I thought about this, and there's probably something missing, and there's probably something wrong. But we have faulty hardware. We have special faulty hardware is golden, right? You have a bad DIM. Sometimes we have bad DIMs that we value more than our good ones because they're so rare. They reliably reproduce a problem. We can put them in a machine and see things. But the problem is, it's hard to come by things that fail exactly the same way all the time, everywhere. So we end up using special hardware, JTAG, or things like a lot of CPUs have special debugging tools we can hook up. BMC can sometimes do things and it can even drive the scan-like features sometimes. We can do EI and J from ACPI. That was what I was talking about earlier. And sometimes you can just have software that does something kind of screwy and will trigger the hardware to do something. So like reading a non-existent function in PCIe will get you a UR. So I'll refer to this. What I'm going to do is I will sort of bookmark, copy the bookmark, and I will say injection. Let's see. Okay, so that'll if someone clicks that, it will take them to the bookmark I just added.
from the requirements perspective, right? When we talk about this at scale regression use case, not having hardware touch points in order to do this error-based injection, or there are two aspects, right? One is a reboot, a hard reboot, that's generally required if we are kind of enabling this flow. And sometimes, like for JTAG and all, we also have actual touch points like a jumper setting on the platform to enable that data path. So,
Right.
so when this operation has to be done at scale, maybe reboot is still fine, but hardware touch points may be inhibiting in a way.
Yeah, no, I'm with you there. I agree with you. We do not want hardware touch points for at scale. And that's the value of talking about these use cases, because if it's a lab injection, then, you know, if I need to put a jumper in or something, who cares? But if I'm doing this on 10,000 machines, you know, that's kind of hard to go have someone run out to the data center and put the jumpers on. So that's, I guess that would be, so maybe what we'll do is say constraints. And like example would be no hardware enablement on injection scale. Need, oops, on B.
Do we need to make the distinction between what you're calling spoofing versus injection, or are these use cases only for error injection?
What do y'all think? That's a good question.
Because spoofing is valuable too.
Yeah. So maybe we say for spoof injection, and then that is you know, is it a spoof? So then in the use case we say spoofing or injection use case. And that may be something we put in each use case. All right, good call. Oh, is that what you is that okay, Mita?
Yeah, yes, thanks.
Awesome. Okay. So Scott, you've been super quiet today. We're out of time. Was this therapeutic?
It always is, yeah.
We're all suffering the same problems.
No, I'll go in and I'll update some stuff on the doc.
Okay, I was just joking because I know that you're wiped out at the end of the week. But, so
Thank
awesome. That'd be awesome. Yeah, hey, that'd be awesome if you had some stuff. Okay, well, I think we're out of time, but maybe that'll be the next step as we fill out some use cases. And I'm going to continue to reach out to Anil. Yeah, we just want to make sure that we give him a chance to investigate the in-band stuff, and anyone that's interested, you kind of enable him to go off and work on that and drive something if that's still a big concern for him. With that, I think we're done then. So Vilas is here, but I'm going to go get a drink of nice hot tea and think about him. And then the harder stuff comes later.
Thanks.
All right. Thanks, everybody. Talk to y'all later.
Thanks.